scanner allows you to gather information from a device over the network without you needing any particular username, password, or any other type of authentication to that device. You simply send it some well-crafted queries, and by examining the responses, you can find out a lot of information about that device. At its most basic level, a port scanner can tell you if a device is responding to you over the network. It'll send a ping or an address resolution protocol query to see, is that device really alive? And if it is, it can examine and see, are there any open ports on that device? Does that device have services running on it that allow someone to connect over particular port numbers? What are those port numbers? Which ones are open and closed on that particular device? You can also find out a lot about the operating system running on that device, even without connecting to that device or querying the operating system directly. You can send some very specific queries, and depending on what's returned, you can determine what type of operating system, and in some cases, the exact version of the operating system that's running on that device. To get even more details, you could scan the open ports to find out how do they respond to queries. And depending on the response, you can determine what services might be running and what version of what services might be running on that device. If you're managing a network really of any size, there's going to be a need to monitor the devices connected to your network. And an easy way to do that is through interface monitoring. We want to know at a basic level, is that device alive or is it not alive? Is it on the network or has it dropped off of the network? We want to get some lights that tell us, is everything green or is a section of the network gone red? And an interface monitor can provide you with that information. It can also provide you with alerting of that information. You obviously can't look at the monitoring screen for 24 hours a day, 7 days a week. So we'll have the software monitor these interfaces. And if the interface turns from green to red, it can send you an email or send you a text message. Interface monitoring software can often not only give you that short-term view of what's happening, but it can collect information over a longer time frame so you can see how available a particular interface has been. If you need more detail than just is the device up or is the device down, you may want to look into other monitoring technologies like SNMP. They can give you information about interface utilization, errors, and much more. It's often useful to get an understanding of exactly what's running over the network, and there are a number of packet flow monitoring technologies that can do exactly that. A very popular way to do this is with a technology called NetFlow. NetFlow version 5 and NetFlow version 9 are the most common ones that you'll see, and it's designed to look at these traffic flows across the network and provide you with detailed metrics about exactly what's running over your network links. You'll generally use two different components to make NetFlow work. The first component is a probe. You're going to put a probe on the network at every place where you want to collect data. The probe is going to watch the raw traffic going by, and it's going to create these summary records, and it's going to send those summary records back to a single collector. That way you can have multiple probes on the network, but all of the summary information is being sent to one central point, and that is the NetFlow collector. It's at this collector where we're generally going to be able to run a number of reports because all of the data is contained on that collector. There's usually a separate application you would run that queries the collector, looks through all of the summary records, and provides you with information about what's flowing over the network. Looking at this view of NetFlow statistics, you can see this summary of metadata can actually provide you with a lot of details. Here's the top 10 nodes by response time. You can see these top 3 are having loss, and so they're having some very long response times. You can see the exact nodes that are having the packet loss. Here's the devices, the top 10 that are having high utilization, so you can concentrate on trying to find out why those devices see so much traffic going by. And of course, there's other reporting mechanisms. Here's a report that shows the top 20 applications. There's World Wide Web, HTTP, SQL Server, Oracle SQL, domain name server. So you can really get a lot of detail about exactly what's happening. And it's very common to be able to run these short and long-term reports so that you can start doing some troubleshooting of your network flows. Another technology you can use to gather detailed
Okay, so that's about some of the network monitoring tool. You know that you can do the port scanning. You can see what's the IP address available, and from the IP address available, you can see what's the port available here, and from that you read this information about the application available. right? And you have the interface monitoring up or down. You have the packet flow monitoring, the network static, and you have a protocol analyzer. What you do with the Wireshark, right? The Wireshark in that you have the tab here between the router and the switch. You can see what's really going on, and you without interrupt the service here, or you can work with the you can work with the. Let me see. Or you can work with mirroring here, right? You work with mirroring here. So instead of the send it to the switch, you also copy the version to the protocol analyzer here. Right? Send A to here, send the copy A to this one, send B here, send the copy B. So we see you can see every going on with the interface of the one you want to monitor here without interrupt the service. Okay, and also we have to remember that you have the network interface card in the promiscuous mode here. Promiscuous, that means you can able to capture for every error packet. Right? You have the run packet or giant packet here. So we see when you have information about run packet and the giant packet, you can take the action to investigate and to dig it down what really going on here. Okay, and you can have the event viewer in the window. That is very straightforward, right? Very straightforward. Or you have able to configure the syslog message here. Syslog is a utility for generating, sorting, and processing the message about the event in the init core or in the here. The syslog standard addresses three primary components. You have event message format, you have event message transmission, and you have event message handling here. And basically for the syslog, it defines the role for each computer that participates in the logging here. The first one is the generator, so the one who generates the error here, generates the log message here. Right? That is a device that monitored by the syslog compatible application and issues the event information. Right? So think about if you think about in your network, right? Normally you have a dedicated syslog server here. It will work with a syslog here. You have syslog server. Syslog server, it is a connector. It's a connector. And every other device, a computer or router or the switch, you are the generator. Generator. So what happened here? What's the thing about? You have some error or you have some event. Trigger the alarm. It send it to the syslog server here. Send it to the collector here. Send it to the collector here. And of course, if you are the network administrator, you can set for the what type of alarm you want to connect along. You see, if you want to collect every alarm, very soon you are overflow of the buffer, and it's very hard for you to do with the troubleshooting. Right? See, you have a lot of very unnecessary error or log. You don't need to know everything about that. Right? You need to focus on critical alarm, on emergency alarm here, not for everything alarm. And you can change the severity of the alarm. You see, if you want to collect all of them, or you just want to connect it from the sum of the level of the alarm. Okay, so that is a severity alarm level here. The first one is the emergency, that it is a system unstable, right? So something about what really will you have the outage in the network here. The second one, you have the alert. It immediate action. You need to take it here. You have the critical, you have error, you have warning, you have notification, and you have informational, and you have the debugging here. So it works on the severity here. The first one is more critical, and you have to take action immediately. And actually, you will have the outage in the network. Right? And also, the second one, the alert and critical here. And if you are the network administrator, it is your responsibility. You set the severity level. What is the severity level you want to collect it on? I see. If you want to collect everything here, more of information about this one. Very soon you got the overload with the buffer, and very soon it's very hard for you to dig it down what's going on here. So if you want to collect about information about its full information and you want to pay attention here, you can take it from everything from emergency to to the warning here. Right? So this one is in the package. So I have the simulation about this lock here. I have information about this lock here. I can show you about the. Yes, this one. Okay, so for this one, it's just very simple network. I have the simulated very simple network here. Is that one? Is that one I configured at the system observer here? This one the collector, collector, and every device here, every device on the network, they are generator. So if the link going down or link going up, you can send it to the system observer. And from the system observer, you have the software, you have the application, and you have the monitoring. You have the monitor, and it can keep check and can monitor what's going on with the network. Right? So for this one here, you can see I do it on the network. Okay, so first thing that I want to collect, right? I want to collect every information about timestamp, right? What time, right? What time, what day, and even go to the millisecond or so. Right? So when any alarm, any alarm coming, I have the idea of what time of the alarm here. Right? Also, you see on this one here, right? I see on this one here. I configure for the login and the IP address. That is the IP address of the NTP server. Right? So any error, any log generated from my router is send it to the system server here. Right? And I have the logging chart here. The logging chart, the debugging, that means I want to collect every information. Right? I want to collect every information on this one here. So basically, this is when I configure the logging chart, the debugging, that means I able to collect every information from debugging, informational, notification, warning, error, critical, alert, and emergency. Right? But if you want to connect, if you want to set it a warning only, that means you only able to connect it for the warning, error, critical, alert, and emergency. Right? So for each of the so for this one, I have the service. I have syslog here, and think about if you work in the network, you have the monitor, right? And you can capture everything what's going on here. So right now I don't have any log for this one. Right? So see what happened here. If I shut down the link here, it's a G0 shut 0 here. Right? So I go to the router, I shut down. Okay, so when I shut down, when I come back to the syslog, you see it automatically generates the error, right? And send it to the syslog here. So I have information about this one. I have the time, I have a date, I have timestamp, and also I can see what's going on here, right? And this, I know that this one going down. So see, if you are the network administrator, it's very helpful for you, right? You see, you can collect it. You can collect every error from every device on the network and send it to the syslog server, and from that you can see what's going on and you can take the action if you want here. Okay, now another tool that more of the large networks they use, it is SMTP. SMTP is a simple network management protocol here, and organizational often used in the enterprise-wide network management system, which the following entity work together. They have the network management system, NMS here. It collects data from multiple managed devices at the regular interval in the process for call the polling here. So think about it, set every 5 seconds or every 10 seconds, you collect the log from the owner of the managed device here. Right? And many devices, any network nodes monitored by the network management system here. You can configure it, right? So if you want to monitor the router or the switch or the server, you can configure them at the managed server. Managed device here. And you need a network management agent. It is a software routing that collects information about the device operation and provide it to the network management system. You can think about network management system. It is dedicated server, and you want to collect all the information from the managed device here. And you have the management information base. It is a list of objects managed by the network management system here, as well as a description about this object here. That is a list of the object type. If you want to monitor something, you have to define what object you want to monitor, and you want to get the information here. Okay, so see for this one here, you have network management system at the dedicated server here, and you collect all of the information from the managed device. They are all of the managed device with the network, and they call the agent here. And of course, for each of the device here, you must have the MIB for the managed device. And also you have the MIB here for the network management system here. It's a managed. So in the case of SMMP, yeah, most agent use SMMP is a simple network management protocol. It is a part of the TCP/IP source, and you have three versions. You have three versions of the SMMP. The first one is a SMMP version 1. It's original version, and it's rarely used today. The reason it's not used today because it's in the plain text. It's not security, plain text. And the second one is SMMP2. It's improved SMMP version 1, which increase the performance and slightly better security. And the most common nowadays is SMMP version 3 here. It adds authentication. Authentication is about the username and password, validation, and encryption that enhance security here for the message chain between the managed device and the network management protocol here. So basically, for when you configure for the SMMP here, you have the network management server, it's dedicated server, and you collect all the information from the managed device here. So all of them here, you can think about they are the managed device, and they call the agent. And remember that for every managed device here, you always have the MIB here. It defines the list of the object you want to collect it. And in the case of the SMMP, you have the two ways to collect the information here. The first one, you actively send out the request here. So think about if you are the network administrator here, you want to see what is going on, right? So see, send me your utilization here. And when you send the request, right? You request to this guy here, send me your utilization, and this one give you the response. My utilization is 70%. That is the case you actively request it to the manager. The second one is chat here. The chat is you set the limit for this one. I think about this one. You set the limit for utilization here, 70. Right? So basically, if he work with the 65% or 50%, it is totally normal. Right? But if the utilization here greater than 70%, he will actively send it to you at the chat here. So when we set the chart is 70%, so whenever you go to the 71%, it will actively send out the message to you and tell you that right now I am over the limit. Right? Okay, so I think this one.
In this video, we want to consider the operation of SNMP, Simple Network Management Protocol. SNMP has been around for a long time. We've got a few different versions of SNMP out there. First, let's take a look at some of the basic building blocks of SNMP. First, we have some sort of an SNMP server that we refer to as an SNMP manager. This SNMP manager might be part of an NMS, or Network Management System. For example, Cisco has the Cisco Prime infrastructure that would fall under that category, and the SNMP manager is going to receive information from managed devices. And these managed devices, we call them SNMP agents. And as we see here on screen, a switch could be an SNMP agent, a router could be an SNMP agent. We could have lots of devices in our network, including other servers, that could run an SNMP agent and respond or send information to an SNMP server. And inside of these SNMP agents, they have something called a MIB, a Management Information Base. And different types of devices can have different MIBs. A MIB contains a collection of object identifiers called OIDs, and these OIDs define what information on a managed device can be read or even set from the SNMP manager. And information can be exchanged in a couple of different ways between an SNMP manager and an SNMP agent. For example, the SNMP manager could query an SNMP agent and ask for the value of one of the variables in one of the object identifiers in a device's MIB. So we could query, we can pull information from an agent. However, the agents, they can proactively send notifications up to an SNMP manager. And this notification is called a trap notification. These agents can watch for certain thresholds to be exceeded, as an example. And if a particular threshold, such as CPU or memory utilization, exceeds a certain value, without waiting to be queried, an SNMP agent can proactively tell the SNMP manager, hey, I just exceeded 50% of my processor utilization. And to summarize what we've talked about thus far, we said that SNMP is made up of really three primary components. An SNMP manager that's going to send queries and receive trap notifications, SNMP agents, the devices being managed, and in each of those SNMP agents we have a MIB, a Management Information Base. And something else we should understand about SNMP is that it's available in different versions. To give you just a bit of a history lesson, when version 1 came out, the security was not all that great. SNMP devices used community strings, which we could think of as passwords. And there was a read-only community string, and there was a read-write community string. And if somebody had an SNMP manager and they pointed to a device running SNMP, they could query information from that device if they knew one of these community strings. They could read information if they had the read-only community string, or they could even set values if they had a read-write community string. And one of the big challenges that I used to notice back in the 90s, I would get equipment from different vendors, and almost all of the vendors had the same default community strings. It was very common for the read-only community string to be public and the read-write community string to be private. And I would guess that many devices got installed in networks that had those default community strings. Not very secure. And interestingly, in version 2 of SNMP, security got a lot tighter, but it was difficult to set up. And as a result, version 2 itself never really caught on. There was a variant of version 2 that caught on, and that was version 2C, and that's very common in today's networks. And version 2C gave us some of the feature enhancements that version 2 had. For example, version 2 allowed us to retrieve a lot of information from a managed device with a single query, and we would need to send fewer queries to get the same amount of information as compared with SNMP version 1. However, because the security was so complex, the security was rolled back to using, you guessed it, community strings again. And that was version 2C. More features than version 1, but not more secure than version 1. Well, the great news is today, version 3 is starting to catch on. And version 3 does give us good security. It does encryption, it does integrity checking, it gives us authentication services. And from a design perspective, you should probably go with version 3 if you have that option. And now that we have this overview of SNMP operation, in our next video, we want to see how...
Okay, so that's about the identity. Okay, so we also have the performance baseline. Performance baseline is what is a baseline? Baseline is the report of the network normal. You remember that baseline is a report in the normal situation here. It's a normal state. in normal state of the operation, and might include a range of acceptable measurement here. So think about what is that? Think about it very simple here, right? So if you are the network administrator, you keep monitoring the utilization in the backbone, right? So think about you have the backbone here, it's support for 1 gigabit per second, right? And the utilization here is in the range from the 50% to the 70%, and you think it is a normal, right? And you can think that is a baseline. So baseline in the network is that the utilization in the backbone is everything in the range from the 50 to 70 here, right? But what happened here, if somehow you observe it up to the 90% or reduce it to the 10%, you know for sure something wrong here, right? There's something wrong. So that is the reason that you always have to maintain the baseline in the network here. It is a report of the network normal state of operation and might include the range of acceptable measure here. And the network performance baseline obtained by analyzing the network traffic information and includes the network backbone utilization right here. That is thing about the backbone. That means it is the way you connect to the outer internet here, right? And have the number of the user log in the per day. So think about normally you have about 100 login user, but what happened here is normally in the range of about 100 to the 150, but somehow you see that you have 500. For sure, something going wrong, right? Yeah, something going wrong here. Also, we have the number of user login per day per hour, number of protocol. Also, number of protocol. You can think about how many applications. Right? So normally you have a 10 application or 20 application here. And also you have the error static. You have the run packet. You have the Java or you have the giant here. Also, it can be the frequency of application use. Right? How often you use the application here. But you can see something with abnormal in application or some bad guy do something wrong, you can detect it here. And also, it have bad edit, you see it here. So we see for this one here. This one it is an example of a baseline for the, you can think about for the backbone here. You can see actually you can see they have the variable a little bit, but the pattern is quite the same. You see, it's pattern quite the same here. So you see every Monday and the Sunday you have a low, right? You have a low utilization here. You have Sunday and Monday here. So you see even that they have the variable here a little bit, right? But totally fine with this one. Right? That's why the baseline is the one you monitor in the normal state and you keep check and see what's going on with the network. Okay, so baseline measurement is served as a basic comparison. Right? Remember, you use a baseline here to compare. It's something abnormal, right? Something abnormal here to comparison for the future performance increase or decrease caused by the network change with the past network performance. You can compare the most critical network, user function, more data provide, more accuracy here. And you have the several software applications can perform baselining. This software range from the, you have the some of freeware or those expensive here, and it totally depend on your network requirement here. And you have the sum of the common performance KPI. KPI is a key performance indicator here that can be the device availability and performance. It can be the interface statistics. You have the utilization, you have error rates. It can be the packet drop and this here. So you can think about the KPI is everything about some of the key performance indicator here. So think about the packet drop, right? So if you want to maintain about the packet drop is not greater than 1%, 1%. So you can set it the KPI, right? So the KPI for the packet drop here is 1%. So if everything greater than 1%, you can configure for it trigger the alarm and show up on the monitoring table. You have the red alert or the yellow alert here. Okay, and the bandwidth management is the most common one. You see that if you have the congestion on the network here, it's you know there's something wrong with the bandwidth here. And the bandwidth management refers to the collection of strategy to optimize the volume of the traffic at a network and support. You have the three techniques might include any the following the technology. The first one, the flow control. Flow control you learn in the TCP, right? You remember about when we learned about the TCP, transmission control protocol. I think about its flow control is that here. Flow control is that when you send it to the from the source to destination here. So what happens if the destination overloaded? He not able to handle it. He's not able to handle it here. So you have the way to from the destination here. You have to tell the source, please slow it down. Slow down here. So basically, when you work with TCP, when you work with TCP transmission protocol, control protocol, it is connection-oriented protocol. It's reliable, and the reason it's reliable because before you send the data, you have the handshake. You remember that you have the handshake from the source to destination. You have to agree on the sequence number. You have to agree on acknowledgement number, and you have to agree on how much. How much data I can send. At the beginning, you think about I handshake with the destination here. At the beginning, I can send for 100 megabit per second. That is a sliding window here, right? But somehow this guy here, but sometimes he's overloaded, or you have the congestion during from the source to the destination. You have to slow it down. That's why you can maintain about flow control here. And you can configure the interface and protocol balance the permitted traffic volume. It's a device capability for handling the traffic. You have a congestion control. It adjusts the way network respond to indicate to indication of the network performance usually caused by traffic congestion, so they don't make the problem worse. Now think about this one here. So basically, for when you work with the TCP, right? When you send it here, right? Normally you expect for acknowledgement. You expect it here. But if you have if you have the congestion, actually this acknowledgement here make things worse, right? Because you keep waiting for the acknowledgement here. Why you have the congestion here? So somehow acknowledgement here is not always good, right? So see in the case of congestion here, you might disable acknowledgement here, or you can reduce the time. Right? So think about normally you waiting for 15 milliseconds to wait for acknowledgement here. Now you can reduce it only for the 5 milliseconds. Now if more than 5 milliseconds, you understand that something wrong, you can recharge meeting instead of waiting for 50 milliseconds. Right? That is all the thing about the congestion control. It is the way you behave in the case of congestion. Right? See, you can disable acknowledgement here, or you can change the timeout here. And you have the quality of the service. Quality service, that means you can prioritize the service there, right? See, everything here, everything share the same physical connection here, but in the case of congestion, you have to set someone is a higher priority and someone have a lower priority here. I think about you have the voice over IP, you have a video online, right? You have to set it with a high priority. So in case of congestion, you have the right to go first here. Okay, you have the flow control. Flow control, it is a bandwidth management technique here, configured on the local connection between the two devices. The purpose ensure the receiver is not overwhelmed with the rate of data transmission. Right? So that in case that you send it too much, you have to slow it down here. Right? And the common approach for the flow control, including here, stop and wait method. You have a go back and sliding window method, and you have a selective and repeat sliding window method here. So that is a stop and wait. That means whenever you send one frame, you have to wait. You have to stop and wait until you got acknowledgement here. Now we move to the second one, and so on and so on. This one is very, very reliable, but very slow here. See, one by one, very, very slow here. Now the second one is go back and sliding window over here, right? So see, instead of sending one at the one time, you can send for multiple. You can send for multiple one, right? And send for multiple one, and also this one also send with acknowledgement for multiple one at the same time. Right? But you see, if something wrong, right? Sorry, something wrong with the window here. You can think about this window. This is one window, and this one. This is the second window, right? So if something wrong with this window here, now you can retransmit for all of the sliding window for this one, right? So this one work faster, right? This one here, wait, send and wait, send and wait, send and wait. Now you can send parallel, right? At the same time. And the third one is a selective repeating sliding window. The same, you work the same with the sliding window here, right? You can send it parallel at the same time, right? But for this one here, instead of sending the whole window, you can send on selected. Right? You see, if you receive the number 4 and receive number 6, but not 5 here, you see, you only able to need to send the file again, not the number 4, not number 4, and not number 6 here. Right? This is the most effective one when we work with the sending from the source destination here. Got it? You got it or not? Yeah. Okay. Now we have a congestion control. Congestion control technique are designed to prevent the congestion before it occurs. Normally, you have to anticipate it, right? And you have to design it. So what you behave in the case of the congestion. Right? So normally you have to design to prevent congestion before it occurs here, or they call it the open loop congestion control, or also remedy the congestion after it's already started here. They call it the closed loop congestion control. So we have two ways to approach it. The first one, it is open. That means you have to anticipate it, and you have to do it before the congestion happens. And the second one is the close here, closed loop congestion control. That means when you already have the congestion and how we behave in that case. Right? So in the case of open loop congestion techniques, you include the sum of things. You have a retransmission approach here. Retransmission timer have reduce the increase the congestion. I see. Sometimes it keeps the retransmitted, it's not good, right? If you have a congestion, actually it makes worse, getting worse. So in that case here, you can reduce, you can reduce the timer in the case of the transmission here. You have a window policy that sender might be required to use a selective, right? Selective, you see, it's more effective, right? Selective repeats sliding window to reduce the number of frames that must be present here. Acknowledgement policy, receiver can require to send a single acknowledgement message for multiple receive frame here. So instead of the send one by one, you can send one acknowledgement for multiple frame here. Sometimes it's a thing going worse here. You can have use a discarding policy that if you have a less sensitive frame, you can discard it. You have to sacrifice it for the more important, for more sensitive frame here. Sometimes you have to sacrifice it. And you have the admission policy. The router and the switch can temporarily reject new traffic, totally shut it down. It overloaded already. So more traffic come, it makes things worse. That's why you have to slowly shut it down. You can temporarily reject the new traffic that will contribute or create a congestion rather than admitting the new traffic here. Okay, so that is open, right? That is in the case open. That means you have to design before the congestion happen here. Now, in the case of the congestion already happened, right? You have the sum of the technique here. You have implicit signaling that sending device detect congestion. The sending device detect congestion on the network after it experiencing the several missed message here. So think about this one. You are the source here, and you send it to the destination here, right? So normally everything goes smoothly, right? You don't receive any, you don't miss any acknowledgement here. But somehow, if you have some time, you see that you have to wait for a long time to get acknowledgement, or you miss all of the 5 consecutive acknowledgement here. So we know that something going wrong, right? So that in that case, you have to actively reduce the data you send it to the destination, right? Okay. So see, normally it works smoothly, but you see, at one time you can see that you observe that you have a more than 5 consecutive miss of the acknowledgement. You know something for sure going wrong. Right? That's why you have to slow it down. You have implicit signaling. It's a congested networking device, so might be the router, or it can make router on the way, right? So from the source to the destination here, you have to send it to router and send to the destination here. That implicit signaling, it is a congested networking device. So we think about the router here. Router here, it can change the existing data packet to the indicate is a sender or receiver. You have the network congested. So we see if the router detects something, you can send it to the source, or you can send it to the destination to tell something going wrong. You have a choke packet. It's a router. experiencing the congestion and create and send the chirp packet to the traffic source, informing the congestion so that the sender can reduce the rate of the transmission. And you have a back pressure in the node downstream here from the sender to receive, stop accepting the traffic, transfer pressure to the congestion upstream. It notify the upstream here. Okay, and you know that you have to use the QoS, right, quality service, because not service are equal. You have some more important service, some more sensitive service, more than other one here, right? So think about the voice and video transmission. They are very delay sensitive. Very delay sensitive. That's why they call it the loss tolerant here. So in order to prevent the delays, disorder, and distortion, you have to require more dedicated bandwidth. Now you see, in the case of this one here, right? In the case, every application you share the same link here, right? Now for the voice and OIP here, they are very sensitive. So you can reserve one lane for them. You can think about this one. You have the multiple lane, right? You have the multiple lane. And you can reserve this one here. You can reserve the one lane here for only for the voice and video traffic, right? But other traffic here, you can move around whatever lane it is. Right? This one fast lane, this one the fast lane here. Right? So you can see when you go on the interstate road, right? Some of the roads they have the fast line here. Yeah. And you have the QoS. It's a group of techniques. A group only one, not only one, right? It's a group of techniques to adjusting the priority of the networks side to various type of the transmission here, and optimize the QoS translate into the uninterrupted, accurate, and faithful reproduction of audio or video input here. Okay, so in the QoS you have the in the QoS you have the sum of the techniques. The first one, traffic shipping or the packet shipping here. It involves the manipulating packet. Manipulating the packet, that means you have to accept in the packet. You have to change the information here. So in that case here, if you remember about the encapsulation of the IP version 4. Is that you have data, and is that you have the header here. Right? In the header, you have information about the time to lead information. You remember that? You have information about type of traffic here, thought here. That is the one you were able to manipulate it. So you can set the priority for this one here. The traffic shaping goal includes assure the timely delivery of the most important traffic, offer the best possible performance for all users here, and traffic shaping can involve delay select important traffic. Right? Of course, you have to give the higher priority for the sensitive, right? The buoyant traffic here, and of course, in that you have to sacrifice for other one. Right? That's why you have to delay for the less important traffic here, right? And also, you have to put it some in the buffer, and you increase the priority for the more important traffic. You limit the traffic volume flowing in and out interface during specific time period. Right? You have to limit it, or you limit momentary throughput rate, for instance here. And this two technique here, they call it the traffic policy, because you have to limit something here. That's why they call it the traffic policy here.
One way to provide this prioritization is through packet shaping. You might also hear this referred to as traffic shaping. This is where we can apply certain bandwidth usages or data rates to a particular type of application. This means that we might be able to set certain applications to have a higher priority on the network than other applications. And of course, there are many different ways to implement this. This may be provided in a firewall, in a router, or inside of a switch. If we're setting these priorities of different applications and prioritizing by the amount of bandwidth or traffic rates that an application uses, we often refer to this as quality of service. This is a very broad description that allows us to define the process of controlling these traffic flows across the network. There are many different ways to implement quality of service across many different topologies, but there are certain standards that you'll often see used on most people's networks. One of those standards is the class of service, or COS, that you can configure on an OSI Layer 2 network. This is a type of prioritization that is performed inside the Ethernet frame header in an 802.1q trunk. So this is very specific to communication between switches. This is something that we would commonly then perform inside of our own intranet because we don't commonly have a trunk connection to our internet service provider. If quality of service at layer 2 inside of a trunk is a bit confining, you may want to implement diffserv. This is differentiated services, and this is a type of QoS that you're able to implement at OSI layer 3. With diffserv, we're modifying quality of service bits within the IPv4 header. These bits are usually set outside of the application, so you would usually have a device on the network that would recognize the application and then set the proper bits inside of the header. Normally, this would be done inside of routers or inside of firewalls that have this diffserv capability. These values that we apply inside of this IP header are differentiated services code points, or DSCP values. These are set inside of the IP header in a very specific field called the DS, or differentiated services field. In some environments, you may take advantage of both class of service and diffserv to be able to set the proper priorities for the applications and devices inside of your network.
Okay, so actually you have many techniques in order to set for the QoS. This one you can limit the traffic here, right? That's why you have the traffic policy here. You can limit it. So we can set it. You can set it the throughput here, the bandwidth here is 100 megabits per second. So anything greater than that will be dropped here. It will prevent in the case of the congestion. You have the several types of traffic prioritization here. You can prioritize the traffic by the protocol, by the IP address, by the user group, by the DS black here is the IP packet, and you have by the VLAN tag in the data link layer, and you have the service of application. So basically, for the QoS, you have many ways to approach it. Right? You see, you can set it based on protocol. You can set it based on protocol. You can set it based on protocol. Think about you want to reserve some of the traffic for the final IP. That's a protocol, right? Or you can set the priority based on IP address. So you think about if you have the server, right? You will communicate with the internet here. You want to reserve specific bandwidth for this specific IP address of the server. You can do it, and you can also about the user group, right? So basically, in the window, for any operating system here, you can break it down in the group, right? Some of them you have employee, some of them they are HR office, right? Some of them they have accounting. So based on the user group, you also able to set which one has the higher priority here. And this one here, that is black in the IP packet. Right? In the IP packet, you have the header on the IP packet, and in that one you have the type of service, and nowadays they call it DSCP here. DSCP here, differentiated control protocol here. You can set it as a core protocol here. You can set it based on the priority of the packet. In the VLAN also, VLAN in the case, you remember that you went with the VLAN, right? So think about we have the switch here. You have one switch and you have another switch here. Now for this computer, so think about this one, you have a VLAN 10 here. And this one you have VLAN 20 here. And you send it to this guy, VLAN 10 here. And this guy you have VLAN 20 here. Right? So in order to communicate between the two switches here, you remember that you have to call with this one, the chunk here. The chunk is the one who carry for many VLAN here. Right? This one is access mode, that means only support for one VLAN. And chunk it carry out for multiple VLAN. Basically for every VLAN. But how? If you send it to in the chunk here, how can you know which one belongs to the VLAN number 10? And how can you know which frame belongs to the VLAN number 20? In that case, you have to work with the tag here. The tag here, that means you have the frame here, right? You have frame, and before that, you have to put here 10. That means you know this is traffic number 10, right? Or you can put the number 20 here. You know that it's a traffic number 20 here, right? So by work with the VLAN tag here in the data link frame, you can modify this one. You can modify this one here. You can set the priority for the VLAN here. So you can think about this one. I can set the higher priority for VLAN number 10 and lower priority for the VLAN number 20. This one work with the class of service in the layer 2. Yeah. And of course, you can work with the service or application. You can define for specific application. So think about you need more bandwidth for the voice over IP core, or you need more bandwidth for video on demand. You can set it on the application here. Okay, this is a layer 3 technique here. Deeper recent service that you can modify. You can modify in the IP header. You can modify in the IP header here, and you can use the first 6 bits in the field. They are called the DSCP here, service code port here, and you can define the 2 forwarding types. The first one is expedite the forwarding. The second one is assure forwarding here. It is the data stream assigned for minimum departure rate, and the data stream assigned for different router resources level. And the COS here, it is layer 2. That means when you define in the frame in the layer 2 here, in the switch, in the case of inter VLAN, right? You know that in the case of inter VLAN, you have to put the information about the VLAN number. That's case you can set the priority for the VLAN number here. It can range from the 0 to 7, and the reason that it only works from 0 to 7 because it only has the 3 bits. And you know the 3 bit 2 raised to the power 3, you have 8. That's why you have 0 to 7. So that's why you can set the level from ranging from 0 to 7, and you can set the priority for it. Any questions so far, guys? I just keep talking, but no one raised any question. Any question?
None for me.
So basically for this one, you are supposed you have to read it before you come to class, right? You have to read about the reading assignment before you come to class. Otherwise, it's very hard for you to digest it. You at least you have something in your head. You know something in your head. That's why I always recommend that before you come to this class, you have to read this something first.
I listened from the Udemy.
What? Okay. So now we move to the plan, response, and recovery strategy. So what happened if something goes wrong with the network? How can you react? How can you behave if you have something here? What happened if you have the network outage? What happened if you have the congestion? What happened if you have the server going down? You only have the policy to do it. That is a response and recovery strategy here. So disaster and security breach do happen. Always, whatever it is, the network always has sometimes you have the network outage or you have the security breach or happen here. And that's why for the reason you have the training and preparation. You have the good for the preparation, and you have the good training for the employee to tell them what they supposed to do in the case of the network outage, in the case of something wrong with the network here. So training and preparation can make all the difference in your company ability to respond and adapt to this situation. An incident is any event that has adverse effects on the network availability or resources. It could be the security breach, infection, or environmental issue. And disaster is the extreme type of the incident involves the network outage. It can be the flooding, in the case of the fire. Yeah, that's the disaster here. So in the case, this we will have the sum of the strategy and how you behave, how you react to the incident here. You always have a good incident response plan here. You have to list out what is action you have to follow in the case of the incident here. So normally you have the 6-stage process in the case of the incident when it occurs here. The first one, the preparation here. You have the detection and identification. You have the containment. You have remediation. You have recovery, and you have the review here. So basically, for the preparation, what you have to do, what you have to prepare in advance. You have in the case of the incident happen here, and now what's something going wrong, right? How you detect it and how you identify what's going wrong here. And you have our containment. That means you have to narrow down it. You have to narrow down it. You have to narrow down problem here and try to prevent it, to impact to another problem here. And now you know the problem, right? And you narrow down the problem here, and you contain it into the segment of the network here. Now action, you have take action to remedy it here, right? To change it here. Now when you done it, right? When take action to recover it, you only have to review. You only have to write down what's going on here and what is your action. You only have to put about the lesson learned here, right? So that's very helpful in the case the future. It's the same thing happen again. Now we have the data preservation. That is a step to take in order to safeguard sensitive information, log data, and other legal evidence until the first responder or incident response team can take over. Right? So you only have to secure the area here. You have to document the sense, monitor the evidence and data collection, protect the chain of custody, monitor transport data and equipment, and create the report here. Now you have the disaster recovery planning. That's about all of the steps, very in the detail step, how you react and what you are supposed to do in the case of disaster here. You have the business continuity. It's the ability of company to continue doing the business with the least amount of interruption as possible. When you plan for the disaster here, you only have to think about the business committee. Try the best to mitigate the problem here. Try the best to maintain the business here. Right? And disaster the recovery plan details the process of the restoring the critical functionality and the data after an outage here, and it might include a contact name and phone number of emergency coordinator. Right? So what happened here? If the server goes down, you always have the policy here how you need to contact. Right? So the first thing is that network administrator. Right? That's the first step. Right? Or we call for the network administrator or the network support here. That's the first step. Now, even the network administrator or network support here not able to do it, you have to escalate it to the vendor, right? So now server belong to the Cisco. You have to, do you have information about the Cisco support team or not? Right? All of them, you have to list down everything into detail, and you have to work on the escalation plan. Right? Call to the first level, to the second level, to the third level, escalate to the vendor. Right? You have many things to do. That's why you have to maintain about the contact name and the phone number for emergency coordinator here. Okay, you also have the detail on which data and server are being backed up. So we see that in order to maintain the reliable network, you always have to maintain the backup very often here. You have to copy compression from router, from the server, from the switch. You save it, you keep it in the safe area here. So if something going wrong with the router, you can take out the compression. You can recover it on the compression here. So that's why you have to determine which data here. So normally after you back up for router, so you have to put the route, you have to put information, right? You have to put in on the detailed information here. Think about router, you choose the router number 1, and you have to specify what date, right? You have the 25th and March and 2025. So we'll see. When you come back to the comparison here in the backup, you know what day you back up, right? So you can roll it back and can recover the router or the switch here. You see how frequently you back up. You have to clarify it. You have to back up based on weekly basic or on monthly basic or on daily basic here. Where the backup cap, so normally you have the server here on isolate. You can send all of the backup information to the dedicated server here and keep backup data, right? How to backup data can be recovered in full. Also, that is very important, of course, right? For every network, when you design it, you only have to maintain about the topology. You only have to maintain about the network document here. So see, if something you're going wrong with the server, you have to look it on the physical topology, right? You know what room it is, what floor it is, what floor it is, what room it is, what rack it is, what shelf it is. So we can narrow down and come to the specific server to do the action here. Also, topology, you have the logical topology also, right? You see what is IP address, what is the port number, what is the VLAN information here. Also, you have the redundancy in case that you want to enhance the reliability of the network. You only have the redundancy, right? So in case of the think about it, you have the active, right? You have the active server and you have the passive here. So if the active server going down, you know you have to activate the passive here. It is not automatic here. Or you have some of the some of spare part, right? You have some of spare part here. Okay, so we also at least you know where you store the spare part and which one it is. So if you have the one card in the router going down, you have to know how to locate for the spare part and take it out and plug it in, right? Okay, and you have the agreement with the national service carrier. So we have for everything with the think about if you as a if you are organization, what is it? You have a contract with the internet service provider, right? So what happens if you're going down? You also have to escalate it to the internet service provider here. And you have a regular strategy to. Okay, this one also very important here. You have to kind of testing here. You have to type that thing, right? So we try to shut down the server and shut down the router to see how it behave, how the network behave, how the employer behave, if they follow the policy or not. All of the thing here. And also you have the plan for managing the crisis. Okay, so the disaster recovery contingencies, you can have into 3 categories. You have the cold side, you have warm side, and you have hot side here. Sorry, hot side here. Cold side, it is a component to rebuild the network access, but they are not appropriately config and update or connect. That's why they call cold here. You have warm and you have a hot side. Okay, and so I think that is the last one here. That is the power management, right? If you want to maintain about everything stable, yeah, you have to make sure you have to stable power supply here. Right? That's why you have some of the some of the equipment here. In the case that what happened in the case of source, noise, and brownout and blackout here, and sometimes you need to use a UPS here, that interruptible power supply here, right? Or you can have a standby UPS or online UPS. Okay, so I think this all its information is about the definition only. You can look it on the book. So I think that's all. That's all for this class. You have any question?
I'm struggling with one of the mind taps with one of the live virtual machines. Can you help me with it real quick?
What?
I'm struggling with one of the live virtual machines. Is it okay if I share my screen and can you help me out with it? Or...
Which one is it? Which one?
11.1.
11 for
It's just this one certain part that's not working out.
this one.
Yeah, that's it.
What is your problem?
I'm on task 3. Step 1. And it wants me to enter in a 0-0 at the end of it, basically, but it always says invalid input detected at the 0-0. But I'm entering in. I thought I was entering in what it asked me to. But I'm on slide 3, task 3, step 1.
Can you share the screen?
Huh? Oh, do you want me to share my screen? Okay. So do you want me to share my screen?
Yes.
Okay. So this is the step I'm on. I've entered this in numerous times, every time it said.
Okay. In the voice.
Oh wait, I get it. Never mind. I'm in the wrong. I think, no wait, never mind. Wait. I thought I was in the wrong one for a second there, but then I found out I changed the host name.
Okay, so what? Okay.
I thought that this is what went in. Does that look right? Or
Can you hit enter? Okay, so this one. Now let me convert this. Let me see what. This one, right?
yeah, this is the right one. But I'm on like task part 3 or something. Yeah, I'm on task 3 currently. But yeah, we could start there if you want, at the beginning if you want.
Okay, so you have the gigabit Ethernet G0/0/1. Yeah, you can do it. Can do it here.
Okay.
Oh, yeah. Or you can try the shortcut here. You have INT that interface and you have G0/0. Try it before or not.
I still got an error.
There was an error.
Yeah, it says that the dash wasn't supposed to be there or something.
You are on the correct router.
Yeah, I'm supposed to be doing it in NY Core 2, and I'm doing it in NY Core 2.
Two.
Yeah, I'm doing it in NY. Oh wait, I think I see the problem now. It's supposed to be NY Edge 1, not NY Core 2. Okay, there we go. Okay. Let me see this.
think that on the NYHU, you also able to do it. I don't know why.
I think I got it to work now. I think I'm okay now.
I see. Yeah, something I want to. Yeah. Okay, this one. This one.
I have a question.
What is it?
So on the modules, like the scroll one up when it just has the March 8th, so it only has 5 assignments. When you go into the grades and like you can see there's more for March 8th, but I don't know if it's stuff that you've taken out that isn't a part of the modules anymore, but I just wanted to double check and see if anybody else saw that, or if you understand what I'm saying, or if I need to show you like what I'm seeing.
Okay, let you to share the screen. Oh no, sorry. Can you share the screen? What's the question?
Okay, sorry. Let me share. So for my March 8th, it just has these 5 assignments, and then when I go in to it has more than 5. It has these and then these 3 as well. I don't know, and when I go to click on them, because they don't match up with what I see in my modules tab, when I go to click on them, there isn't like anything for me to do.
Okay, so if it's not in the module, you don't have to do it. Hello?
Hello?
But my point, so if you are not able to find it in the module, you don't have to do it. Keep it blank, you don't have to do it. No?
I'm sorry, can you say that again?
Okay, so let me share.
I think that the class used to be a little longer, but then they took some material out or something. And that was from
Okay.
like from the original one, basically.
Okay, I just
Am I
wanted to
right?
make sure.
Yeah, is that correct or am I wrong?
Is that correct?
Okay, thank you. I just wanted to make sure that I was doing all of the work and not missing assignments.
Oh, can you assign me on this? Okay, so we see everything is a module. It does that. That's the one you are required to do it. Otherwise, you don't have to do it. Okay.
Okay, that's fine.
Yeah, for this one, I want to talk a little bit about this one here. We learned about the last part about the DHCP snooping, right? What is the DHCP snooping? What is it? What is the DHCP snooping? On the last class, we learned everything about the security, right? You have some about the ARP, you have about this DHCP here. What is a DHCP snooping? Any idea? Hmm?
Snooping.
Okay. So the SCP snooping, you think about this one here. So remember about the process about process of DHCP. DHCP is a dynamic host configuration protocol. That means when you get the IP address automatically, when you got the IP. So you have the 4 process in the DHCP here. You have DORA. You have DORA here. That means you have discover. You have offer. You have request, and you have acknowledgement here. Offer here. Sorry, discover. You have offer. You have request. And you have acknowledgement. That's the process when you want to get the automatic IP address. The first thing here, you go to the network and you don't know which one is the DHCP server. That's why you send out broadcast message. Send out broadcast message, and you tell that I want the IP address. So when you send it to the broadcast message, normally it go to the DHCP server here. DHCP server. And in the DHCP server, you have the pool of IP address. Some already occupied, some is available. So he can check it out one from this one. We have 192.168.1.100 here, and he offer it to you. So how about 192.168.1.100? Do you want to use it or not? Now, if you want to use it, you send out request. I accept the 192.168.1.100. And let's one as the last one, he acknowledge here. Now you can use the 192.168.1.100, and of course he mark it unavailable. That's the process of the DHCP here, DORA here. But in the case of DHCP, you have a huge problem because it is a broadcast message. See, yeah, it's a broadcast message here. You discover here, you actually send it to everyone. Everyone here. So what happened here? If this guy here, it's a bad guy. Yeah, he pretend he's a DHCP server and he give you wrong information about the default gateway, about DNS information. So from that here, instead of sending to the correct default gateway, you just send it to him, and he send it to the default gateway. That is a case of DHCP server. Yeah, that is a case of DHCP server. So now let me show you the simulation here. So we have the help from this server here. See this open here. See. Yeah, this is open here. Okay, so you can look on this one here. You can look on this one. So basically, this guy here. This guy is the legitimate one. Sorry. This guy here, DHCP server, is a legitimate. So basically, okay. So basically here, every PC on the network, every PC on the network got the IP address from the DHCP server. So we can see. You can click on this one here. So go to desktop here. I go to the IP address. I change it to static. Now, what happened? I click on the DHCP here. Yeah, you got it right automatically, right? So see the default gateway here, 192.168.1.1. It is the default gateway of the router, right? Also, you can also have the information here. So if you want to configure it, but for me, I do not configure it. So basically, see in the normal case, right? In the normal case here, you take this one at the default gateway, 192 here, 168.1.1. So see, if you go to the internet, if you want to go there, you always send it to the default gateway here. The same with this one also. Same with this one. So I get it automatically from the DHCP server here. Yeah, I got it from the automatic IP address .12, and the default gateway is correct one here. So now what happened here? I think this one is a bad guy. The bad guy here. Now he connected. He connects. So he connect it to the switch. And he connected to F0 start for here. Now see what happened here. If I go back to this one, change it here. In the packet tracer, very hard for me to simulate it. So I think it should be better if I shut it down. This one here, shut down the port here. What is the port? F0/1. Okay, so now what happened here? Let me see. Let me shut down the port F0/1 here. Okay, so now see what happened here. I go to the PC here. See, I got the IP address correct. I got the subnet MAC address correct. But you see, the default gateway here is not the IP address of the router anymore. Actually, the default gateway here it is the IP address of this guy. So now, from now on here, whenever you send it to the internet, you send it to this guy. It's a bad guy here. And again, from this one, you forward it to the default gateway. So now see, actually he is a man in the middle here. You can see anything going on between you and the internet here, or another one here. Instead of sending it directly to the default gateway, now you have to send it to him, and he send it to the forward it here. And again, if this one here receive it forward to this guy, and this guy forward it to him. That's the program of DHCP spoofing here. So in order to do that, you know that something you're able to do that. You have to configure the DHCP snooping for this one in the route in the switch here. You have the IP DHCP snooping. That's the first step. The second step here, you have to configure this one here. Sorry, you have to configure this one. It's a legitimate one. This is your chat port. Chat port. That means you know for sure. This is legitimate DHCP. So you know that you tell the PC that if the PC got you tell the switch that if the switch got the DHCP offer from this one, accept it. Because it's a chat port here, but any other port, they are unchat port. So see, if this one unchat port and this one send out the offer, the switch is the one who blocked it. So even that he plugged it in, but he have no way to get the information to the computer with DHCP. It makes sense. So that is the case of the DHCP snooping here. So in the homework for this one, I think log out already. Security here. Security here. Packages. I said list, right? Yeah, this one. For this one, actually, for this one here, this guy work as a DHCP server. So normally for the small network, you can configure the router as a DHCP server. So you can do it. But so normally for the large network, you have to dedicate the DHCP server. For the small network, you can configure the DHCP as a router here. So in that case, you know that you have to configure the IP DHCP snooping in the switch. Also, you have to configure this one. That's all. So you see, whenever the offer the IP address, you accept it, but any other one, you do not accept it. Yeah, that is the purpose of this one. That is why you have to do with this one here. Yeah, so I think that's all. Any other question? Let me know. Hello?
No questions for me.
Okay, so that's all for this class. So we don't have the class on on Wednesday and Monday because it takes the time to do with the final.
Thank you.
Yeah, and anyway, I will available on the Zoom. So if you need any help from me on Wednesday and Mondays, you just feel free to join the Zoom meeting. And you have any question, anything is that coming up with you, you can raise a question to me. I'm willing to help you.
So this is our last time in this class then?
So yes, that is the last time.
Okay.
Yeah, we did everything. And let's see here.
Thank you for letting us have those days off to practice on the exam and stuff. I've been making a study guide and stuff, and this will help me make it better and stuff like that. Am I allowed to use notes when taking the final?
It's a 15 mark. It's a next few days. No, that. Yes, next Tuesday. Yeah. Yeah.
And this will, yeah, that post assessment, will that, you have to post that because that isn't in my,
No, you don't have to do this one.
okay.
So am I allowed to use notes on the tests on the final, or am I not allowed to?
You can do whatever you want.
Okay.
What is it? Yeah, so see, you still have a lot of the assignment here, so take your time to do it. Take your time to do it. Tomorrow, this one,